Welcome back to my Rust course. In this video we'll talk about variables. I've created a new cargo project where we'll write our code. Let's start with variable mutability. If I define a new variable with the let keyword, in this example I've defined the x variable to which I have assigned the value of 5. This variable is automatically of type integer now. This variable is immutable by default. What this means is I cannot mutate it afterwards, or if I try to assign another value to it, for example 6, and I attempt to build the project, let me first save, I'll get a compile time error telling me I cannot assign twice to an immutable variable. To make this variable mutable in Rust, I have to explicitly say it's mutable with the mute keyword. Now, if I also print the value of x twice, before the mutation and after it, and if I run the project, it will compile successfully and I get the two values of x as expected. You might be wondering why make variables immutable by default. This actually enforces pretty good style and allows you to catch a lot of errors. First of all, it makes you think twice before making a variable mutable and mutating its value, as in many cases this is not the best course of action. Second, it allows you to catch mutability errors early by having compile time errors. You frequently do not actually want to mutate an existing variable, but rather redefine something. So this feature, I would say, is quite useful. The next concept we'll talk about are constants. To define a constant in Rust, you can use the const keyword. By convention, constant names in Rust are all uppercase and separated by underscore. I'll define a constant for 1 hour in seconds. Constants need to have an explicitly defined type. For this constant, I'll use u32. We'll talk about types later, but u32 is an unsigned integer type in Rust. And they need to be defined to a value when they are initialized. In this case, I'll set the value of 60 by 60, which is exactly 1 hour in seconds. If I print the value of my constant, I can now use it as expected. My program runs and everything is working correctly. Now, you might be wondering, what is the value of the constant construct when we do have immutable variables in Rust by default? And you'll be right to ask this question. Constants are conceptually different from variables. First of all, constants can never be mutable. If I attempt to add the mute keyword, I'll get a compile time error. They also need to have an explicitly defined type and an expression that is evaluated at compile time, because constants do not reference an address in memory. They are a value evaluated at compile time, while variables are evaluated at runtime and they reference an address in memory. That's a very big difference, and because of that, constants can also be used in the global scope, while variables cannot. If I put this constant in the global scope, I'll still be able to use it in my main function. The project will compile and run as expected. But if I attempt to define this variable in the global scope, I'll get a compile time error. The next concept we'll talk about is shadowing a variable. Shadowing, as we mentioned in the guessing game, is redefining a variable. I'll remove the mutability of my x variable and keep it with the integer value of 5. Let's say that I want to redefine x as a string with a value of y. I can do so in Rust by using the let keyword to redefine it. In this case, in Rust, we can say that x is shadowed. Now, if I run the program, I get a value of 5 and then y, as expected. You might be wondering, why does shadowing even exist as a concept when you can just make the variable mutable? First of all, if a variable is mutable, you cannot change its type. If I attempt to do this and change x to a string, I'll get a compile time error. If shadowing didn't exist, like in some other languages, you would need to redefine a new variable with a new name, for example xstring, which is not optimal. Second, you can use shadowing to scope a variable. If we have a local scope here, let's say that in it we change x to the string of y and we print the value of x inside of it, we can now Set the value to 5, print its value, then in the local scope shadow it to a different value, print it, and then go back to the initial value of 5. If the variable was mutable, when we mutate it here, it wouldn't go back to its previous value afterwards. Let's run the project to demonstrate what is happening now. You see we get the value of x is 5, then in the local scope we change the value to y, and that prints. Then we go back to the previous scope, and here the variable is not shadowed, therefore we get its original value of 5. If the variable was just mutable and not shadowed, even if we didn't change its type, we just redefine it to 7, for example, reassign it to the value of 7. If I now run, you can see that the value of 7 persists after the local scope. As the local scope, this reassignment will just reassign a new value to this same variable, while shadowing creates a new variable. With this, I'll wrap today's video. We talked about variables, constants, mutability, and shadowing. Don't forget to subscribe to get notified when the next video in the series is released. Take care.